The topic exceeds about the manufacturing process unit energy efficiency balance, uh, material and energy balance in manufacturing facilities, the foundation for efficiency, safety, and sustainability in chemical and process engineering. Why material and energy balance matters. Understanding the flow of mass and energy through manufacturing facility is non-negotiable and for effective operation. These balances serve multiple critical purposes. These directly impact on bottom line and operational safety. Optimization and cost reduction ensures efficient use of raw material and energy, directly leading to reduced operational costs and minimized waste generation. Safe operation is about critical for safe operation by preventing hazardous accumulations or unexpected losses of material, particularly volatile and toxic substances. Environmental compiles essential for environmental needs by tracking emissions and wastage streams. The consumption supporting regularity and reporting is also an improvement of process improvement. The quantitative foundation for optimizing process design, identifying bottlenecks, the significant improving overall production and yields. Now let us go deep into this. The core principle of conservation law is all material and energy balance calculations are rooted in fundamental conservation law, which state that the mass and the energy cannot be created or destroyed. Only it can be transformed to one form to another. On the right side, we can see the control system mass out accumulation diagram, the summing point and different inputs with a controller modular output. The mass in equal to mass out plus accumulation. The principle ensures that a very kilogram of a raw material entering a system can be accounted for either as a product, a waste stream, or as material stored within the system itself. The energy in and energy in equal to energy out plus energy storage. Similarly, all energy entering in heat and electricity must exit the system or be stored within it. Increased temperature or internal energy. These laws confirm that nothing is ever truly lost. It can only change from one location to another location. So the core principle of conservation law is the fundamental conservation law itself. It can be created. The total material balance is measured in the mass, and the overall material balance is also measured in the kilogram energy balance in plus energy balance out. Similarly, all energy entering plus heat electricity increased in temperature and internal energy efficient for true loss changes and locations. Defining the system boundary. The crucial first step in an balance calculation is defining boundaries and system under study. These ensures accurate tracking and all relevant streams. Identify unit list streams and set a boundary. The boundary must be explicitly and identified to list all materials energy stream across it, including raw materials, products, waste, heat transfer, and work input and output. Material balance equation explained. The general material balance equation is mathematically robust and applies both batch for continuous process. Its simplification under steady state condition in particular useful continuous manufacturing. General equation is about input raw material, output products plus waste accumulations and material stored or lost. Steady state process for a continuous process operating with a change over time, steady state and accumulation terms over therefore inputs and outputs. The components otherwise balancely beyond the overall mass balance component, which balances the tracking individuality of the defect and leaks consumption and formation, which is having different modulations and controllers with a finite number of steady state responses through inputs and outputs. The tracking instant calculate input substance does not match output plus accumulated storage. Its signals need investigated potential leaks, measurement errors, and unexpected chemical changes within the system. Energy balance equation explained. The energy balance is a crucial for managing thermal process and optimizing utility consumption, ensuring that the heat used efficiently is not wasted. Energy entering the system typically includes the heat supplied, steam heat coils, work done on the system, the pumps, compressors, and the chemical energy carried by incoming material. Energy output, energy leaving includes heat loss and surroundings through in a inadequate insulations and work delivered by the systems and turbines, the energy carried out product waste streams, and challenges that are undercoming the steady state operations that stored energy change in the storage energy and having internal energy and kinetic and potential materials that within the system simplifies by calculating the balance. Engineers identifying the energy uh, inefficient such as excessive heating loss and reactor are occurring, allowing the targeted strategies for heat recovery and conservation. Step-by-step balance calculation process. The schematic uh, process of ensuring all the materials and energy calculations regions consists of solvable diagram process, choose in basis, write the equations, and solve equations. These selected calculations consist of different types of process diagrams and PFDs, that is having the labeling all streams known as unknown flow rates and consumption of temperature. Choose of basis, select a temperature basing calculation over 1 hour of operation, 100 kg feed up to one batch. The anchors all subsequent calculations right under the equations formulate. Overall material balance and composite balances that distinguish the substance overall energy balance and equation systems. Solving equations, the solving set of simultaneously algebraic equations from all unknown flow rates, consumption of energy quantities. In this require inactive methods of complex process analysis and verify critical analysis and result do not make the physical sense. The calculated values of verify process performance, detecting the confirmed design of specifications. So these are about the balance calculation process. Next one, real world application improving the chemical plant. Uh, Applying material on energy balance move a further theoretical concept and operational improvement for the different mode of scenario that may happen in material balancing and audit. The energy material balances that 5% raw material under different types of minor pipe leak and wastage streams. Energy balances indicates the significant 10% heat loss from reactor and heat exchange due to the decorative insulation. The action and result maintenance terms repair all identically the insulation high temperature equipment and upgraded to the modern high efficiency materials. Wastage streams and previous discharge no proceeded from the internal component recycling. The result was measured 8% reduction in overall optimizing cost, significant reduction and environmental impact, the demonstrably safer operation and leak immigration mitigations. Modern tools and challenges are process controls, simulators, and the data accuracy. The president's challenges, the different types of reliability in real-time process data from instrumentation, sensor and flow measurement inaccurate of validation of balance calculation. Continuous monitoring and regular updating the balance often integrated the distributed control system design that are critical of maintaining, achieving and maintaining ingoing process control and efficiency. The ingoing process control and efficiency with the modern fundamental principle is a industrial scale and complexity of necessary tools and techniques for effective balance system, the computational load, process simulator, and data accuracy. These three are the modern tools and challenges that we face in different types of complexibilities and techniques that affect balance management. Conclusion, mastering material and energy balance, the cornerstone of process engineering. Mastering material in a energy balance is not just an economic exercise, it is a fundamental high value skill set drives modern industry performance. Key takeaways: balances are the foundation of designing, operating, and safely improving all manufacturing processes. They directly enable resource efficiency, cost reduction, and variable sustainability efforts in industry. A deep understanding of principles forecast innovation and competitive advantage of these different types of strategy techniques, and these are the process engineering controls and how the manufacturing unit scalar leakage simulation tools. Thank you.